Hey guys, it's Mr. Bennett. Hope you guys are having a good weekend. We're coming back from the weekend now. We're continuing Unit 2. This is going to be video 2-3, and we're talking about mixtures. Now in our last video, we talked about the idea of elements and compounds, and we actually looked at this picture here. Now, when we looked at it in the previous video, we talked about these guys over here. These would be our elements. They're the simplest form of matter. We can't divide these atoms up any smaller without breaking them up into protons, neutrons, and electrons, which at that point are really hard to put back together. On the other hand, on the right hand side, we have compounds. Compounds are when we have two or more different elements and they are chemically combined. So in your notes right now, I'd like you to make a note that the compounds are chemically combined. That means that they're held together with bonds, and if we were to break them apart, we would need a chemical reaction to do so. We can't separate a compound without a chemical reaction. Today, we're going to talk about mixtures. And the thing about mixtures is that they are physically combined. What that means is you don't necessarily need a chemical reaction to separate them. In some cases, you can use physical means, meaning something like a filter or some other means that we'll talk about in a little bit. But the idea here is they are physically combined. So again, on your notes, I'd like you to write down by the picture that these guys are physically combined. Notice that even though these two different elements are in the same area with element X and element Y, they are not actually connected with chemical bonds. So you don't have any chemical bonds joining the two substances. They're just mixed together. So think of this one kind of like a salad. This would be like your lettuce. This would be, I don't know, cucumbers, tomatoes, celery, whatever it is you add to your salad, right? Over here, this would be something more like kitchen-wise. It'd be the equivalent of cooking your egg. When you scramble an egg, you can't undo the egg white, right? You can't put it back to being clear. You can't take the egg yolk and put that back to being liquidy anymore either. Once they're combined, it's going to take a pretty serious chemical reaction to undo that. Whereas a salad, you can pretty much pick it apart, right? Okay, so let's talk a little bit more about compounds versus mixtures. Just to review, a compound is something that is combined chemically in fixed compositions, and it creates something new with brand new different properties. The big thing about compounds is that the element you began with is going to join with another element, and the properties of the compound that you make are completely different. Mixtures, on the other hand, contain two substances that are combined physically, not chemically. They can vary in composition. To give an example, for instance, in a salad, you could have some salads that have lots of lettuce, some salads that have very little lettuce. You could have salads that have lots of tomatoes and salads that don't have tomatoes. So they can vary in composition, but we still call it a salad. Also, the substances that were used to make the mixture, meaning these two substances here, or if you've got a salad which is made up of lettuce, tomatoes, cucumbers, and maybe other things like peppers or something like that. Multiple different substances, but they all retain their own properties. The lettuce still tastes like lettuce, the tomato still tastes like tomato, the bell pepper still tastes like bell pepper. Okay, they retain their properties. Compounds, on the other hand, were completely different. Mixtures, the pieces that are mixed together still retain their own properties. So salad, again, lettuce, tomato, cucumber, etc. Now, when we look at mixtures, there are two different categories. The first category is what we call a homogeneous or homogeneous mixture. The parts of the mixture are uniformly distributed at the microscopic level. Now, let's talk a little bit about this name here. So the prefix homo means same. So the way I think of it is these types of mixtures are the same throughout. So no matter where you look at it, whether you take a sample from the top of the mixture, you know, if we have, for instance, a cup and we have a homogeneous mixture in here, whether I take a sample from up here or down here or to the side, every single sample, no matter where I take it from inside this mixture, will have the same uniformly distributed parts, meaning how whatever parts of the mixture I find here will be in an equal amount over here and over here. It's the same throughout. So examples of this would be something like milk, where if you have a glass of milk, the milk tastes the same at the top as it does at the bottom. The gasoline in your tank of your car, right? It burns just the same at the beginning as it does at the end. Salt water from the ocean, same at the top as it is in the bottom. Now, with the exception of sand and things like that. But if you were to just take a glass of salt water, the top would be the same as the bottom. Same with syrup, okay? Air as well. They're the same throughout. There is a special category of homogeneous mixtures known as a solution. A solution is when you have a homogeneous mixture in which the components mix and they form one phase. So what that means is that we take the different parts, and they could be something like a solid and a liquid. We combine them to make our solution, but when we're all done, it's all liquid. So for an example of this, think of something like Kool-Aid. So Kool-Aid comes as a powder, right? You add it to water, and when you're done, you get Kool-Aid drink, right? Which is just one phase. It's liquid. So what we've done is we've taken a solid and we've taken a liquid and we've combined them to create a solution that we call Kool-Aid. And that, even though we combine a solid and a liquid, when we're all said and done, it's all in one phase. And phase is simply just the state of matter that it takes on once a substance is there. So in this case, it would be a liquid. The second category of mixture would be a heterogeneous mixture. So hetero, if we talk about that prefix, means different. So these guys are different throughout. Homogeneous was the same throughout. These are different throughout. And all that means is that it's not uniform. So at different parts of the solution, you're going to get different amounts of the substances. Again, a mixture is a combination of two different substances. So for instance, orange juice, if you take a carton of orange juice, right? You guys ever notice that orange juice has a shake well label on it? That's because you have your orange juice, right? And then if you just let it sit in your refrigerator, all the pulp, all the little pieces of the orange drift down to the bottom. So you have all these pieces down here. And if you don't shake it up, then all the pulp will continue to just collect at the bottom. So when you get that last glass of orange juice out of the carton, it's going to be almost like chewy because it has so much pulp mixed in. So you shake it to evenly distribute the orange juice, evenly distribute this pulp throughout it. Now, if you let it sit in the refrigerator for a little bit longer again, it will separate out and the pulp will again drift to the bottom. Same with a chocolate chip cookie. Chocolate chip cookies are not the same throughout, meaning that there are chocolate chips. If we have a cookie, there might be 3 or 4 chocolate chips in this section. Maybe over here there's only like 1. Maybe over here you'd get like 2 chocolate chips if you took a bite over there. Maybe this section over here there's nothing, right? Have you ever gotten that chocolate chip cookie where there's like 1 chocolate chip in it and you just feel robbed? The idea is that chocolate chip cookies, you're not guaranteed to get the same amount of chocolate with each bite, right? It's kind of random and, again, not uniform throughout. Now, one important thing about mixtures versus compounds is the idea of how to separate them. We said that with compounds, right, compounds have to be chemically separated, right? So think of like the C in compounds standing for chemical. They're chemically combined, they have to be chemically separated. Mixtures, on the other hand, can be separated through physical or chemical means. Depends on the type of mixture and how you want to do it. So physical examples will include things like filters, evaporation, centrifuge. You could allow the solids to settle out, something we call decanting. The 2 big types of mixture separations that are physical that I want to talk about are distillation and filtration. Distillation is how they actually distill or concentrate alcohol. So they essentially take and they boil off the alcohol, which has a lower boiling point than water. Okay, so the alcohol boils off. They then collect that alcohol by condensing it. So you basically heat up the alcohol, and then you cool it back down and collect it in a separate container. So we call it distillation. And you have to have different boiling points for that to work. So the requirement is different boiling points. So the substances that are mixed must have different boiling points. Okay, the second thing I want to talk about, the second separation method, is filtration. This is generally used to filter solids out of liquids. The solids get trapped in a filter. That's why it's called filtration. We use this a lot. So in your car, you have a fuel filter that pulls solids out of the fuel so that it doesn't get into your engine. Another example would be a refrigerator filter. So if you have water, purified water coming out of your fridge, you may have a filter in there that the water flows through, and all those solids, the different metals, the different minerals that are in the water that you don't want to drink will get captured by the filter, and then the liquid, the purified water, comes out, and that's what you drink. So now that was physical. Okay, chemical separation generally involves a chemical reaction. That's why we call it chemical separation. So what you do is you use a chemical reaction to pull one part of the mixture out. Okay, this may be the part that you want, or this may be the part that you don't want, and then you leave the other behind. So that's the end of video 2-3. Make sure you fill out your notes and make sure that you complete the whisk now that you've finished watching the video. We'll see you tomorrow.